I'm Anil Kumar, and here is a review question on this chapter of understanding asymptotes. The question is, write equations of rational functions for the given asymptotes. So we have three questions here. The first one is horizontal asymptote y equals to 0 and vertical asymptote of x equals to 2. So you need to write an equation. B is horizontal asymptote y equals to 0.75, that is 3 over 4, and no vertical asymptote. And C is oblique asymptote y equals to 2x plus 1 and vertical asymptote x equals to minus 1. You can pause the video, answer the question, and then look into my suggestions. Now if you can answer this question, that means you have understood the basic concepts about horizontal, vertical and oblique asymptotes. Let's begin with the very first one. Horizontal asymptote y equals to 0 and vertical asymptote x equals to 2. Begin with vertical asymptote. So let us say we want vertical asymptote at x equals to 2. That means denominator is 0 for x equals to 2. So x minus 2 is a very simple way of making that sure. Now we say horizontal asymptote is y equals to 0. If that is my denominator, then numerator degree should be less than the denominator degree, right? So we could write any number here. Simplest way of writing is 1. So 1 over x minus 2 will be our function which will satisfy these conditions. So that becomes the solution for these conditions. Next one here is horizontal asymptote of y equals to 0.75. Now this time the horizontal asymptote is not y equals to 0 but a different number, right? In that case, degree of numerator and denominator should be same. That is what it tells you. No vertical asymptote means, let's say a function is g of x. No vertical asymptote means the denominator is never 0. So we could say the denominator could be x square plus 1. Now x square is never negative, so the denominator will never be 0. So that is ensured that there is no vertical asymptote. Now we need to make horizontal asymptote along the line y equals to 0.75. Now 0.75 is written as, you can say 75 over 100 or 3 over 4, right? Dividing both by 25. Now since the horizontal asymptote is 0.75, we should have same degree for numerator and denominator. So it has to be quadratic function in the numerator. Let it be x square. That is the simplest way. 3 over 4. Coefficient of numerator is 3 and that of denominator should be 4. So this will ensure 3 over 4 as horizontal asymptote of 0.75, correct? So that is how you get this equation. Now let's look into the last one, which is oblique asymptote y equals to 2x plus 1 and vertical asymptote of x equals to minus 1. Now how do you get this one? This is indeed very tricky. Now, oblique asymptote is when you divide, that should be the quotient, right? So let me write this as a quotient, 2x plus 1 plus some remainder. And with the remainder, let us say remainder is 1 divided by vertical asymptote x equals to minus 1. That means it should be x plus 1. You get it. So this equation will have a vertical asymptote at x equals to minus 1. Perfect. And that becomes your oblique asymptote. So that is how you get your equation. So at times you can actually simplify this, kind of write it as one term. So if you do that, you get common denominator of x plus 1, and here you could say 2x plus 1 times x plus 1 plus 1, right? And expand and simplify. That is not really required. This one is good enough. But anyway, now let us do it. So we'll just multiply these. So we get 2x square plus 2x. With 1 we get x plus 1 plus this one also plus 1, correct? So we have 1, 2, 3, 4 and 5 terms divided by x plus 1. Let's combine these terms. We get 2x square. 2x plus x is 3x plus 2 divided by x plus 1, right? So that is your function in a different way, right? So but both are right answers. Vertical asymptote will be x equals to minus 1. Now since the degree of numerator is 1 higher than denominator, it will have an oblique asymptote. Now if you divide this expression, quadratic equation, by a linear expression x plus 1, you will get quotient as 2x plus 1, remainder will be 1, and you can write this in this form, correct? So either way, you could write that as an answer or this one. This is good enough. I hope with this you understand how, for given asymptotes, you can always write down the equation. I hope that helps. Thank you and all the best.